Well, g'day, welcome back to the shop. So today's video, we're going to be using our tool and cutter grinder here to grind a 60-degree threading tool, as we have to cut a M30 by 3.5mm pitch thread for a project that we're doing over in the lathe, in our big lathe. So yeah, we'll go through all the procedures that I use on my tool and cutter grinder here to grind all the correct angles and whatnot. So let's get into it. We need to grind this piece of M42 cobalt high-speed steel into a threading tool bit. We've been here before, haven't we? Let's rectify this issue first. So this is before and this is after. I didn't want to put you through another video of me making another guard for the tool and cutter grinder, but what we made last time seems to be working out fine. Gives us a bit of protection. So we're going to use this 1mm thick 40 thou thick cut-off disc to cut the V shape, the initial rough. Well, we'll rough out the V shape in this bit of tool steel. Then we'll turn it into a thread cutting tool. So no doubt after a period of time we will end up with a bit of a collection of various shape guards and whatnot as we slowly tool up this little tool and cutter grinder of ours. So I just borrowed the vise off the milling machine as well. It's way too big, but it will get us out of trouble for now. We need to get our zero mark lined up on our vise before we clock the vise in. And then same as the milling machine. Just square up the vise jaw parallel to the axis of the table. That way, when we use the graduations on the vise to go our 30 degrees, we know we are going 30 degrees and we can rely on our graduations. So the new wheel guard makes a great mounting spot for a mag base. Bonus. The other thing we've got to do is clock the head into the table to make sure they're both parallel. Otherwise, the table's going to be going underneath the wheel at an angle. So it should be going sort of straight, so the disc cuts. Instead it's going to be going at a weird angle and it's going to get ugly. So let's get it cranked up and away we go. So quite regularly I stop and just check the temperature of the wheel. These wheels do not like to get hot. Once they get hot, they've got nowhere to expand. They tend to go into a saucer shape, and that's generally when things go pear-shaped. But if it gets too hot and goes saucer shaped, you'll hear it loading up in your cut. So yeah, just no rush, steady, steady. It's still way quicker than grinding all that off by hand with the M42 Cobalt with a offhand grinder. I don't wear them very often, but using a cut-off disc like this, I do. Just in case, you never know. Okay, that's our profile roughed in, so we'll swap over now to a cup wheel and we'll finish grind it. Way easier and quicker and more accurate than doing it on a offhand grinder. Okay, we're set up now with our cup wheel. I only ever just tighten these up by hand. I don't use the spanner to tighten them. They don't need much. Got our other guard on. Hear the lawnmower going in the background. I think the wife's out mowing the lawn. And of course, face shield on as well. Right, well, let's fire it up and we'll grind the long edge of our tool, which is this edge here. Now I think I'll stop and get a dressing stick and just relieve the center section of the wheel so it's just cutting on the outside. Okay, I'll just do it with a handheld diamond. Now that's better. You can see now it's only cutting on the very edge of the wheel, not the full face. I'm just going to blue this up with a Sharpie. Just to make sure we're grinding on the full surface. Okay, I can flip the part over and grind the other side. Okay, away we go again. Okay, let's have a look at that. So what we have to do now is put some relief in. So we set this up a bit differently in the vise, and it gives us a couple of degrees relief on either side. So say for instance you're doing a lot of threads with this tool. There's another way around avoiding to grind relief angles. So if you look at the front of the tool, and if you calculate the lead angle of the thread and duplicate that angle onto the bottom of the and the underside of the tool, so the tool sat in a tool post at a slight angle to match the lead of the thread, there's no need to grind clearance angles on the side. That puts it working then the same as a tangential tool holder for threading. Now a high-speed steel threading bit for, well, a tangential type one does not have side relief. You just, when you sharpen it, you just sharpen the top of it. iFanger make a very good one of those, but yeah, do not need side relief as it sits on center, and when they're canted over to the lead angle, clearance is just automatically generated by the radius of the part you're making. Bit of useless information. When I tap the tool back down into the vise, I use the rawhide side of the mallet. I found if you use the copper side, the part can tend to bounce and bounce back off the parallel strip you're trying to tap it down onto, whereas the rawhide side doesn't tend to do that. Another bit of useless information. Right, to get our side relief angle, we've blued up the side that we've ground, which is our one of our 30-degree sides. We've canted the tool up 15 degrees, and what we're going to do is take some trial grinds until we end up with a parallel blue line there, So we're canted up 15 degrees, and we'll probably have to swivel the vise just a fraction. I'll show you once we've taken a little bit of a cut, and you'll see the fresh grind line, the top of it. Initially it won't be parallel with the top of the tool there, and that's where we rotate the vise until that lines up, till that new line lines up with that line. We'll take a cut and you'll see what I mean. Okay, you should just be able to see it there. So that's our new grind line, and you can see that line across there is not parallel with the top line of the top of the tool. So that means we've got to swivel the vise around a bit. So the vise will have to come around like that. So we're grinding more off this end, and we're aiming for a parallel line across there. So I'm just going to move it 1 degree at a time, and it's all trial and error. So when I say it's all trial and error, there is a mathematical equation that'll get you right there the first time, and that's the compound angle formula. Yes, that thing rears its head yet again, and it's a long-winded formula that I don't understand. The other alternative, which I'm going to make up later on, is some tool blocks where you sit your tool in and it automatically places them at all of the correct angles. That's the best way to go. Saves all the mucking around. You just drop your tool in and it's guaranteed to grind the correct angle, clearances and everything. So I'll swivel this vise around 1 degree at a time until our lines appear running on a parallel track. So actually, while I've got the tool in this position, don't be caught out like there would be some people get caught out. You grind your tool with an offhand grinder at the 60-degree angle, and then you put the tool in a tool holder. Now some tool holders are canted up several degrees. Well, as soon as you do that, your 60-degree angle is no longer a 60-degree angle in relation to the workpiece and the lathe, which is, yeah. So when you're grinding a tool in that type of tool holder with an offhand grinder, you have to hold your fish plate on a level horizon, not parallel with the tool or on the same plane as your tool, if you know what I mean. Otherwise you're going to get the grinding slightly the wrong angle. Actually, I'll show you that a bit more clearer when we finish the tool. Okay, you can sort of see now the top of our shiny area there is now parallel with the top of the tool. So what we'll do now is we'll keep grinding until they get a bit closer, and we'll have another check. So yeah, we've got a 15-degree elevation on the tool and 31 degrees rotation around, so we get parallel lines there. So you can see now we've maintained a parallel line between the top of our clearance angle and the top of the tool. I did have to give the vise another 1/4 of a degree, and I may just have to back it off just a fraction. I think we're still a bit thin there and a bit wide there, so I might have come that 1/4 of a degree too far. But what we'll do now is we'll get a measurement from the top of the tool and we'll check and see what our clearance angle actually is, because we've still got time to make adjustments while we still maintain this area of non-clearanced tool. So now it's the time to make a final adjustment. Right, using a bevel protractor, we can check to see what clearance angle we've ended up with. And we've got 8 degrees of clearance. So we have to take into account the lead angle of the thread is deducted from your clearance angle. So this will give us approximately 6 degrees of clearance on our tool. That should be all right. You don't want too much clearance as it weakens the cutting edge. I like to keep it to a minimum. Bear in mind that the material that we are going to be screw cutting is quite a tough material. So that keeps us, or keeps our clearance to a minimum. Now on this side being the trailing edge of the tool, a lot of clearance is generated by the lead angle of the thread. So you can also get away at times with no clearance on that tool, on the trailing edge, as your thread angles away from it. Different story on the lead edge. That's where your clearance is critical, and that's where you really need to calculate the lead angle of the thread, which is, if you look at the thread sort of run at an angle, and that's your lead angle. So our advantage of this design of tool, having a short side and a long side, is when we go to resharpen, we're only got to resharpen one side of the tool. Now, I forgot what I was going to say. Don't worry, it'll come to me later. All right, so we'll keep grinding now, and till we get a full clearance angle up the side there. Once we're fully up there, then we can switch the tool over and grind the main edge of the tool, the business side of it. So let's get our grinder fired back up. Face shield on, because it is a ordinary abrasive cup wheel. I personally don't put any trust in grinding wheels on. Yeah. Okay. Bit hard to see, but our thin blue line that we have at the top there now is a parallel line. So as we're grinding our clearance angle in, we're not changing the 60 degree profile of the tool. So that's why it's very important to keep a close eye on that. Okay, we just zoomed in using the camera on my phone. Okay, that's our thin blue line across the top there. So you can see we're just a fraction thinner up the nose of the tool than back here. So we'll just do the smallest rotational adjustment on our vise and make this correction. It's probably not far enough out that it would affect a general purpose thread, but let's try and get it right. So with the indicator, that's just there purely so we don't lose track of where we started from. So our vise has to come around in a counterclockwise direction, and I'm just going to move it 5 thou on the indicator. Okay, so I'll re-blue the side of the tool up. And we'll have another test grind. So we can see now we're taking more off the rear of the tool than the front, which is what we wanted. So we'll keep grinding away now until that line disappears. Right, let's slip her out. Oops. Okay, there's the first edge completed. All clearanced and everything. So we flip around now and we do the exact same procedure on the leading edge of the tool. Don't be too concerned when you're grinding high-speed steel if it discolours. It can take an immense amount of temperature before it changes the structure of the steel. So, yeah, the bluing and that's, it's nothing. Just ignore it. So I'll get the setup to do the other edge. So I found holding it, my phone, magnify the degrees, makes it easier to see. So yeah, we'll start back off at 31 degrees when we do the other side, as it worked for the previous side that we've just done. So we'll reset our vise, we've reset our tool with our protractor so it's still canted back up to 15 degrees. The only difference this time, we will be using the other side of the wheel, which I'm not generally, I don't like doing, as the sparks tend to come up and it pushes the burr up onto your cutting edge. But it's something that's done. Sometimes there's no option with a tool and cutter grinder. There's times where that's just what you've got to do. So once again, I'll take a preliminary check now to make sure our angles are close. So that's looking pretty close there, so we'll keep grinding until that top section gets closer up, same as the other edge that we previously completed. Okay, we'll check this one out. We're there. Okay, let's pop the tool out. Okay, well that's all of our edges completed. So I just use a flat stone, top and bottom, quick rub, just to deburr it. And you know, I'm very tempted to try this tool with no top with no side rake on the top or back rake. So what we do now is we by hand will radius the nose of the tool just to get rid of that sharp edge, and it will suit the thread profile better with a radius. You can do a radius or a very small flat on the end, or just do a radius. Okay, that's what we want. That sharp edge broken and just a very small radius on there. So we can use our thread angle gauge now and check to make sure our angles match up, which they do perfectly. Now earlier on when I mentioned about angled tool holders, well here's one here. See, the tool is inclined back at an angle. So if you're grinding, say, a threading tool on your offhand grinder, what you do is you hold the thread angle gauge at an angle, a level angle like that. If you hold it like that, you're going to get an incorrect angle. Hold it like that, you'll get the correct angle. It's just an easy point to forget, but it happens. So there's only one thing left now. Let's head over to the lathe and we'll just see how it performs. Like I say, we're not putting any back rake on the top or side rake on the top, so we'll just try it in its flat position, as it is a pretty hard steel, and we'll just see what happens. Okay, we'll try that. That's it, we've got it. Oh, well, that all turned out rather well. We had a good result on our thread over in the lathe behind us. Incidentally, that I'll try and put that job in a upcoming future video, but I've got another couple of things I've got to do prior to that anyway. So anyway, hopefully you might have picked something up out of this about the tool and cutter grinder and some basic tool grinding. So anyway, cheers, thanks for watching, and we'll see you later.